Welcome to Chapter 7, Section 3 video. Today we're going to be talking about renewable energy. There's a growing amount of interest in renewable energy and different renewable energy sources, mainly based on the fact that we're uncertain about the climate impacts that we're having with the fossil fuels we're currently using, and they're also starting to run out. Fossil fuels could be depleted sometime in the next 200 years according to current projections. This is coming up in human history terms fairly rapidly. We've been around a while, and 200 years is not that far out. If you're going to try to scale the entire world over to different sources of energy, it's going to be a process that needs to start soon, just out of basic necessity, if nothing else. There's also problems with nuclear fuel sources. A potentially nearly unlimited amount of energy, all we'll need, but it comes with safety concerns. We've seen this time and time again. There was the instance of the Fukushima reactor over when a tsunami hit it and started leaking nuclear materials over in Japan, and that wasn't that many years ago. Been several other scary scenarios / meltdowns. You look at Chernobyl as the classic example. Lots of concerns there. And the world is generally considering what are the options? Where can we go? How can we get there? One potential option is geothermal. The general idea here is you're either piping hot water up from a depth somewhere down in the earth that is heated. You're going to use that heat to form / steam. It'll turn a turbine, and the power is generated through the process. So to follow that along over here, hot water at depth, it gets pumped up, the steam turns this turbine here, goes around and around and around, generates electricity, and then that goes on to the grid, and water is put back down in where it's injected down to a location where it's heated up by the earth again. This is an attractive option in a lot of places that are geologically active. So think areas with mountains, with active faults, things that are moving and shaking. So San Francisco, Italy are good examples, Japan certainly, and Iceland. Iceland has about 85% of its homes heated with geothermal energy. This is a huge source for them. Another potential alternate form of energy is solar. So here's your trivia fact for the day. Every 15 minutes, the Earth gets enough energy from the sun to power the Earth with all its electrical needs for roughly a year. Every 15 minutes, it gets enough for the year. The problem is capturing that energy. It's not all that easy. Plants are really good at capturing sunlight, and we're trying to get better. There's a couple different ways that we see solar energy captured on essentially a daily basis. The first is passive. Simply put, this is just the sun warming up something. So think your house, if you cut off all of the heat and all of the air and you didn't have anything affecting the climate inside your home, you would notice that during the day it started heating up because the sun hit the bricks or the wood or whatever it was that came in through the windows, and heat started to build up inside your house. This is called a passive system. You're not doing any work. You're not trying to trap it in any way. It's just getting heated. This has been happening on Earth forever. As long as the sun has been lighting things up, the sun's been warming things. Next is an active system. This is using some sort of solar collector. The most simple of these would be something akin to a greenhouse, or if you had a box with a glass lid, the sunlight came in through the clear glass and the heat got trapped. It'll start to build up and you'll get more and more energy, more and more heat. Through time, you can use that sun's energy. You can usually run it through water, and the water can absorb some of the energy and you can convert that. They're solar collectors. The complexity ranges greatly, but it does depend on the sun shining. You can't get energy from the sun if it's behind clouds. You're not getting what you need. To make this happen, they have something called a photovoltaic cell. This is responsible for capturing sun's energy and converting it directly to electricity. So examples here, some of you may have a calculator at home that's a solar calculator or solar powered calculator. They have a little strip. When it gets exposed to light, the calculator turns on. When it goes into a drawer, it powers down. So this is one potential option. Looking at these systems a little closer, passive system, very simply put, like I said, the sun is starting to shine on the house, just starting to rise. Over time, the house will warm up, just passively collecting heat. Other systems, you can have solar banks, solar panels. They are specifically designed to absorb the sunlight. These are frequently lined with lithium and other elements. They collect this energy and they put it into an electrical grid, sometimes straight into your house, depends on the setup. And if we look at a close-up of one of these, again, this is an active system. You're working on capturing this. And if in a close-up of this, sunlight's passing through a series of panels. They got glass. They've got a anti-reflective coating, which means it absorbs more of the sunlight. And they've got a small conductor system, a semiconductor, that will absorb some of this energy and it'll convert it to electricity. So again, just kind of a close-up there. One more we're going to talk about is hydroelectric. So your root word hydro meaning water, and electric obviously standing for electric or electricity. This is made with running water. So we have famous examples here, water running out through a dam. The most famous would probably be the Hoover Dam out in the west. The idea behind these is you're trapping water. You're collecting water out of a river and you're releasing it through a specialized gate. The water runs through this gate, it turns the turbine, and the electricity is generated by the turbine moving. 6% of U.S. energy comes from these sorts of plants. Another one that's gaining some popularity in some parts of the world is tides. So you've got some sort of a wall here. During high tide, all the water flows in. Well, then during low tide, this drops, but you've got all the water trapped over here. So what happens is you open up the gate and the high tide water starts to flow out. Well, you set your turbine up here, it collects the water, and as it runs back out, you're able to turn the turbine and collect energy from essentially nothing more than the tides. Water level goes up, water level goes back out, but you're relying on the water movement. This is where you're getting the energy. Biomass is another option. This is arguably the original source of heat and energy for humans. Campfires. People have been sitting around a fire and cooking meat for a very long time, or vegetables or whatever they had to cook. They probably figured out that it got a little easier to chew and digest if they cooked it first. So organic matter is burned. Occasionally, it's allowed to decompose, and liquids or gases are extracted from it, and then those are burned. But the thing to remember here is biomass is going to include everything living, all organic matter, manure. People have been burning manure, especially dry manure, for a long time. Plants, paper, all of these are examples. And with all this in mind, you have the ability to extract energy from them. Half of all the trees cut down in the U.S., worldwide, half of all the trees cut down are used for heating and cooking. This is still what's being used around most of the world. Last one we'll talk about is wind. So on this one, very simply put, wind is created because part of the earth warms up faster than the other. The sun doesn't evenly heat the entire surface. It heats up some faster than others, and the end result is the wind starts to flow across the surface. Well, people put up giant turbines. You'll see wind farms here, an example. All of these turbines are, here we go, get back out here. All of these turbines, these are giant propellers, they're getting turned by the wind, and they're generating energy. This is the idea behind them. So in these wind farms, they put them in places where the wind is pretty much always blowing, and that's great as long as the wind is always blowing. Everywhere the wind stops occasionally, and when that happens, You get a break in the energy, even if you got it stored up in the battery, you can't run forever, and that's one of the reasons that this can't be the only energy source. Each and every one of these has their ups and has their downs. Some work in some areas, some don't in others. And end result is humans are still looking. We haven't found anything that cheaply, easily, safely replaces fossil fuels yet. And this is a huge industry, and people are actively trying to figure out what's coming next. So hopefully this made sense and helps you understand the material a little bit better.